This challenge question features no new concepts. However, we are using a concept we already learned in a new way. And I want you to think about the rules of this concept as you're tracing through this for the very first time and see if you can understand and deduce how it is that this works before we walk through it together. So go ahead and pause the video here. And I've brought the execution to line 20 and see if you can bring it home to complete the program. So you'll process the function call to combinations on line 20. All right. So what do? Well, first we encounter this function call, and we need to be confident that this is a valid function call. So we ask ourselves, what is combinations? Combinations ID 0. Of course, this is the definition we've seen here. We then compare our arguments with our parameters. So our argument 1 and argument 2 compared with parameters 1 and parameters 2. Prefixes is a list of strings, so that's okay. Suffixes is also a list of strings. That corresponds to the parameters list of strings, so we're all good. We've provided the correct number of arguments and types for our corresponding parameters. So now what we're going to do is push a new frame onto our call stack, and this frame will be named combinations. And it has a return address of line 20, of course. This is where the function call was encountered. And then we have two parameters in this frame, A and B. Well, what are A and B? Well, again, when we're working with passing lists as arguments, hopefully this is starting to become a little bit more comfortable. But we have prefixes and globals is ID1, and suffixes and globals is ID2. These are addresses to locations on the heap. Specifically, ID1 references this particular list of strings, right? So we've set up our A and B. Let's go ahead and establish them as values. So ID1 and ID2. In essence, we've passed references to these lists to these two parameters in combinations. We did not, importantly, as we are learning, duplicate those lists in memory, but we're not going to mutate them in this function, as you've already seen, so they won't change through the course of this evaluation. Next, what do? Well, we reach line 5, we jump into this function definition, and we encounter a new declaration, but on the right-hand side, we have a brand new list being established. So ID3 is going to be a list of string, and it's empty initially. All right. I'm actually going to give myself a little bit more space here. Let's see, I'm going to move this down. Great. And this one, as you all have already figured out, we're going to be appending some longer strings to it. So I'm going to give myself a larger little table here. Cool. So then we encounter variable declarations. Oh wait, we didn't finish this out. So right, we got to be careful here. We evaluated this, and now we need to establish combos in our current frame. Well, our current frame is the lowest frame that has yet to return. That's combinations. So combos is established here. This is the frame we're evaluating. What is combos? Combos is ID3, right? Then we encounter a variable declaration statement. IDXA is assigned 0, so we can go ahead and add that to our current frame. IDXA is 0. Then we encounter a while loop, and we ask ourselves, is IDXA, which is 0, less than length of A? Well, length of A is ID1, so length of A is actually going to be 2 because there are 2 elements in this list. So 0 less than 2 is true. We go into the while loop and we set up a variable IDXB. So let me add this in blue here. IDXB, or index B, is also being initialized to 0, right? Then we encounter a nested while loop, and this is the new concept that we're seeing for the first time. Well, it's not a new concept, right? It's just a while loop. What's new about it is our usage of it inside of the repeat block of another while loop. So let's actually try and break down the syntax here really quickly. Notice that in VS Code, it's drawing these lines that tell you everything inside of a given while loop's repeat block. So this is the repeat block for the outer while loop. And this line is indicating here's the repeat block for the inner while loop. All right. So notice the evaluation, or what I should say is the Boolean expression that we need to evaluate and test is here, and that's going to determine whether we go into this while loop block or just after it, right? But when we get to the end of the outer while loop block, that's what's going to cause us to go up to the top here and test this, and that will determine whether we go inside of its repeat block or whether we skip over it, right? So the same evaluation rules apply, and what we're trying to ask ourselves is about this particular expression here. So we look up IDX_b is 0, and length of b is, let's see, length of b, so b is ID2. ID2 has a length of 3, right? So 3 elements in it. So length of b is 3. Let me actually write this in pen here. 3, and length of a we found was 2 previously. Okay, but we're right here on line 9. We test 0 less than 3. That's true. So we go into this repeat block and we are appending to combos. So remember, combos is this ID that we set up that references this empty lists, right? That's the one that we are trying to build up in this function. So it's currently empty and we're trying to append to it. What are we trying to append to it? Well, we need to figure out what this expression is. So this expression is a IDX a. All right, so we look up a is ID1 and IDX a is 0. So 0 here is the string mega. Right, so the string mega. Oh, switching between my eraser and my pen. So mega concatenated with similar concept. We're looking at what is b. So b is ID2. That's this list here. Index b is 0. So that's this particular item here. So dactyl. Right. So now we have mega concatenated with the string dactyl. And I'm not going to repeat this. We know how concatenation works at this time. What are we doing with that? Well, we're appending it to combos. Remember, combos is a reference to this list here, so we need to append it to this list object on our heap. And at index 0, we will have the string mega dactyl. All right, so cool. We've added a new list to this string. And then what are we doing? Well, we increase b by 1. So the IDX of b is no longer 0. It's now going to be 1. And we go back to the top of which loop. And here's where we have to be careful. And this is the point of this particular example. Again, let's zoom in and think about this. So we've just increased ID of b. Where do we go next? Well, we need to complete this loop, right? We don't go to the nested loop. That would make for some chaotic behavior. The rules of a while loop apply to a while loop, whether it's the only while loop we're seeing, or whether it's inside of a while loop, or even outside of another while loop. So here, the rule, let me undo that. The rule that we're working with is, this is our repeat block. We've just completed it, so we go back up to the corresponding while, right? This is the line that tells us what this belongs to, and we test this again. Right, so we haven't completed what we would call this inner loop. This is the inner loop and this is the outer loop yet. So we increased IDX_b to 1, and I think my undo actually got rid of that. So it's 1. We test is IDX_b 1 less than 3. That's true. So we go back into this block, and yet again we are reaching this expression where we need to figure out what is a of IDX_a concatenated with b of IDX_b and append that to our combos list. Right. So IDX_a hasn't changed. That's still going to be mega. So I'm going to leave this as mega here. Concatenated with b of IDX_b. Right. So b, again, b is not changing in this. B is still this list with 3 elements in it. But IDX_b has changed. It's 1. So now it's the string Saurus. Right. So now we're concatenating mega plus, or concatenated with Saurus. And this is being appended to combos. So once again, these two would come together to form a single string, and we're going to concatenate that to our list here. Oops, I should use a new index. So index 1, and it's Megasaurus. And hopefully at this point, you're starting to see a pattern and a little bit of what is the purpose of this particular function. We're combining the combinations of list 1, right, with list 2. And so far we've combined mega with dactyl and Saurus because we've worked on index 0 of A, right, and index 0 and 1 of B, and we're about to go do the same thing with index 2. And then after we're done with that, we'll hopefully find that we're going to move on to SUPA and combine SUPA with these 3 as well. But let's keep moving. So we increase B by 1, or IDXB by 1. And so now IDXB on line 11 is being increased by 1. So this is now 2. Cool. We go back up to the top of this loop, and now our testing is 2 less than 3. IDXB 2 less than length of B 3. That's true, so we go back in. We know that the IDX of A is storing the string mega in list A. So mega is still what we're working on the A list because its index has not changed. And then B is now, we're looking at the string rex, just like we talked about, right? So we're concatenating mega with rex. And we add that because we're appending this to combos to our lists down here. So mega rex. The next thing we do is we increment B one more time. And so B is now going to be 3. And let's zoom in here. So B is 3. So 3 less than 3 is false, right? So this is false. What do we do? Well, when we reach a false test expression with a while loop, we jump over the corresponding repeat block, right? So we jump over this repeat block and we go down to the next expression or the next statement which follows. That's IDXA is increased by 1. Okay, so IDXA is 0 and we increase this by 1. So IDXA is now 1. Well, we've reached the end of this repeat block, right? So now what do? Well, we jump back up and we test this while loops expression. Notice we're going to test the outer loop this time because that's the block that we've just completed. And we test, okay, IDXA is now 1. We know we just updated that. 1 less than 2, that's true. So we jump in. And here we're resetting IDXB to be 0. Right, so now B is back to 0, right? So the same rules apply. We go into the body of the list, and now we are going to evaluate its repeat block one more time. So IDXB is no longer 3. It's now going to be 0, right? But IDXA has changed towards 1. And so notice that both of these loops have increment statements that are bringing us closer to the terminating statement for that loop being false, right? So we're increasing our indices as we move through the indices of each list. Then we reach this inner statement, and I would encourage you to actually pausing the video here and seeing if you can complete lines 9 through 11 if you didn't successfully do so in the first pass through, or if your diagram was different once we reached this point. All right, so this works just like you saw, or like we've been through in the previous example, right? So previously we iterated through all the indices of B. Those were these 3, and we combined them with mega. So mega dactyl, mega Saurus, mega rex. And we're about to do the same thing with index 1 of A, right? We've increased index 1 of A to be index A to be 1. That gives us the string SUPA, and we're going to combine that with these 3 because we're going to be iterating over this index, right? So that's what this inner loop is doing. But let's work through it. So here we're appending IDXA, that's mega, with IDXB of B, that's dactyl. I'm not going to write these out in this expression. Now that we're comfortable with this, we know that index 0 corresponds to dactyl, index 1 corresponds to mega. We're combining these 2 together and appending that to our list. So list index 3 is SUPA dactyl. Right? And the next thing we do is we increase B by 1. So B is now 1. We go back up and we test is 1 less than 3. That's still true. So we append IDXA, which is SUPA, with the next index, which is Saurus, so of B. So SUPA Saurus, because index is 1, B index is now 1 as well. So we combine these 2, and we're going to add that to our list here. So we're going to append the item Supasaurus. And then we're going to continue on. We increase b by 1. We go back up to our inner loops test, and we're still testing is, oops, I should increase this by 1 so that it's now 2. We're testing is 2 less than 3. That's true. So we go in, and once again, we're appending the concatenation of index 1 of A, that's Supa, with index 2 of B, that's Rex. So Supa Rex is the next item added to our list. So index 5, Supa Rex. All right. And we increase B one more time. B is now 3. When we test is 3 less than 3, that's false, so we skip over it. We increase A one more time, so A is now 2. And now we go back up to the top. We test is 2 less than length of A. Again, length of A is this list here. Its length is 2. So 2 less than 2 is false. So we skip over this and we return combos. Well, what is combos? Combos is the list with ID 3. So what we're returning is a reference to this list. And so the return value here is a reference to ID 3. And what are we doing with that? We're sending it back to line 20 and we're printing this out. And so if we were to print this out, the output would be the list literal. And then I'm going to actually cheat here because it would be very boring for you all to watch me type this out or write this out. And I can promise you on a quiz, you won't have to write this much text. But just to convince ourselves and show ourselves what's happening in this particular video, let me try and finish this out here. So we are deleting this. And I'm going to just put these all on subsequent lines. Again, of course, this is a list literal, so we would have commas following each of these. And I'm going to leave it at that, even though this would be technically all on one line for our output. So let's think about what this particular function is doing and reflect on what are we seeing here with nested while loops. So notice we had 2 input lists initially. We had prefixes and suffixes defined here. So our prefixes were Mega and Supa, and our suffixes were Dactyl, Saurus, and Rex. And we evaluated this function, which has a nested while loop in it. And what it did was it moved through every index in A, right? So this was our pattern here over index A. And then it moved through every index in B for each index in A, right? So for index 0 in A, we moved through all of the indices of B. And then for index 1 of A, we moved through all of the indices of B as well, right? And we can see this visualized in our diagram here with we saw index A updating, and then we saw index B updating, and notice that index B moved through all of the correct indices of this list. And again, what we saw the output of this was, or the result of this was for the first item Mega, we went to Dactyl, we went to Saurus, we went to Rex, and we produced these 3 strings as part of our output list. And then for Supa, we went to Dactyl, we went to Saurus, we went to Rex. Again, all of this through these IDs, and that produced these combinations, Supadactyl, Supasaurus, Suparex. Our output list has 6 items, and there's some intuition here, right? How many combinations of these 2 prefixes and suffixes lists can we make? Well, this is a length of 2, this is a length of 3. You multiply these because we're visiting each of them in each combination of them. So if we had an extra item here, like we don't actually have this, but if we had an extra item like 2 Ultra, we could ask ourselves, how would the output of this be different? Well, it would be different in that we have now 3 items in this multiplied by 3 items in this, and we would have ultimately produced a list with 3 more entries, and those would have been Ultradactyl, Ultrasaurus, Ultrarex. And this is all thanks to nesting a while loop within another while loop, right? And so this particular usage here is handy when we're trying to do something which is, which needs this sort of nested behavior, this combinatoric behavior, right? And the key idea is that I think is a challenge for first-time programmers to get comfortable with is reading the syntax and knowing semantically what's going on. So this is our first while loop. And remember, this had to complete each time. Our index B had to go from 0, 1, 2, and then 3. And then on 3, this was false. And once it was false, we skipped over the repeat block and we reached index A as increasing. And that's what caused us to jump back up to the top and increase A, or test that index A was still a valid index. And then we complete the repeat block again. And the next time we evaluate this, we just do it all over again, right? And that's what we were seeing here. For index 0, we iterated index A 0, we iterated through 0, 1, 2 for index B, and then the same thing for index 1. So the intuition of this is we're moving through every possible combination of the lists A and B to produce a resulting list with all of those combinations. And so this is how you can generate funny names. This is how you can generate different possible outcomes given two particular lists of independent outcomes, and so on. Great work on this one.